Welcome back, students, to the second topic where we'll be discussing something about the irrational numbers and the surds. My name is Kondwani Mithi. Let us be together. Feel free and enjoy the lessons. In case we have some who were not with us in the previous discussion, I will try just to ask you to go back and follow the previous discussion. There's a link down here of what we discussed about the topic 1, where we're discussing about the quadratic expressions and the equations, so that you're connected, because we're going by the syllabus. Today, we'll begin looking at topic 2, where we'll be discussing something about the rational numbers and the surds. In case there might be a need for improvement in some areas that you can cite, please take note of them and link with us so that we can improve on them for the betterment of our program here. The first thing that we need to do, we first of all have to know the aim of this topic. What is the aim of this topic? Why should we learn this topic as students? Here with me is just some aims about the irrational numbers and the surds. Our major aim is simply to help you students to know how to simplify the surds by addition. So it'd be like, do you know how to add the surds? Secondly, by subtraction. That should be in the position to know how to subtract the what? Surds. So it means somewhere we need to discuss what surds are in the irrational numbers. Then after again, we need to also discuss on how you can multiply the surds. The terms which call them as surds, how do we multiply the surds? And then lastly, we need to know the issue about division. How do we divide the terms which we call them as what? Surds. So here, the main aim of our topic, and that's really by the end of our discussion of this topic, you should be in the position to handle the 4 described operations: addition of surds, subtraction of surds, multiplication of surds, and division of surds. Now, to meet this aim of knowing how to simplify the surds, the following are the specific objectives that will help us to move through until we meet this aim. So here with me are the objectives of which will guide us until the end we finish our topic. Right, that's just like now the lessons of which in this topic are categorized as follows. 1, as students, you should first of all to know the meaning of rational and irrational, and then you have to understand what rational and irrational numbers are. So in short, the first thing we are there going to describe rational and irrational numbers. Secondly, after I've known what rational numbers and irrational numbers are, we need now then to discuss the surds. The ones we mentioned earlier, we need to know the operations of which by multiplication, addition, subtraction, and division. What are surds? Thirdly, we're going to express the surds, which we call them surds, in the simplest form. It'll be like, how do we express surds in the simplest form? Thereafter, we're going to discuss something on addition and subtraction of the surds. To say, how do we add and subtract the surds? Is it the same as we do with the other terms in particular expressions? Let's see here the terms which call them surds. How do you subtract? How do you add? Number 5, we're there going to discuss on how we can multiply and divide the surds. You know, division and multiplication, they go hand in hand. The same way you talk of addition and subtraction, they go hand in hand. You cannot work separately on the what? Addition. But whatever we discuss about the addition will be the same for the word subtraction. And this follows again with multiplication and division. Then thereafter, we'll also discuss issues on how you can expand what we call them as conjugate surds. So it will be like, first, what are conjugate surds? There might be new terminologies to you, but by and by, as much we're going to discuss, you understand if we talk of the conjugate surds, means what? And then we need to know how we can expand them. Lastly, we'll have to discuss this objective. That's rationalizing surd denominators. how do we rationalize the stud denominator? And the terminology itself means what? So these are the guided steps in the form of the specific objectives that will take us to the end of our discussion in order to meet the aim of the topic. So by the time we discuss all these here, 1, 2, 3, 4, 5, 6, 7 objectives, you'll be in the position to know how to simplify the stats, and you'll be assessed by that in examination. Right. Now, students, let us now get into business. We are likely going to begin by discussing objective 1, and then we'll go to objective 2, and then we will also discuss objective 3. So in the first lesson of this topic, we are going to discuss 1, 2, 3 objectives at the same time. So please stay tuned. I will not be very fast. There are in the normal way, so that you have to take the skills here. Because the moment you miss on objective 1 and objective 2, then the rest of the story here would not be true. You get lost. So we are there first of all to describe what rational numbers are, and then we'll get to know about the irrational numbers. Secondly, we'll discuss the stats themselves. And then for the first lesson we have, this time, we end with the expressing stats in simplicity form. Now, here we go. Right. From what I explained earlier, for us to know what stats are, we first of all to understand and get to know what rational numbers are. And after, we need to know what irrational numbers are. So it'll be like rational and irrational numbers, they're the ones which are going to introduce us into what? Stats. Because we need to technically understand what stats are. Because the whole business in this topic is operations within the stats. So for us to understand what stats are, we first have to know what rational and irrational numbers are. Now, let's go into the first category. Rational numbers. We have got several types of numbers we interact up with. You can also call them integers. Some numbers are defined as rational. When we say a number is rational, what type of numbers are these? By the definition in my chart, it's simple. For you to recognize that this number is a rational number, here's a good guideline. That these are just numbers which you can be in the position to express them in the form of A over B. Any number, if you feel you can manage to express in this form of A over B, that number is part and parcel of what we call the word rational number. Where if talk of a letter A, which is acting like a numerator in that case, and letter B, which is a denominator in this case, these two letters are representing any integer. Right, A and B represents integer. So in whatever number that you may have, try to express it into this form. Can it be in the form of A over B? If it is possible, then that number is part and parcel of what? Rational numbers. But now if the opposite is true, you can't express that number in the form of A over B. It's just like the opposite, or say the negative of rational. Then those numbers have to fall into what? Irrational group. So that's why here, if you can see here, we talk of the irrational numbers are numbers which cannot be expressed in the form of what? A over B. So it means the whole story about the irrational and rational numbers falls into that explanation. A over B. Can it be in A over B or not A over B? The numbers have been grouped. Right. For example, let's look at this. But we need also to know that here we are talking of any number. We talk of a 5, talk of a 6, talk of whatever. But there's only one number which is not supposed to be represented as the B, and this number is 0. Right? There's no number that can be divided by 0. Try to get your gadget, talk of a calculator, choose any number, and try to divide by 0 and see results that we're going to get. This is just like undefined. Like say if I've got 5 over 0, how come 0 dividing into a number? Is that possible? Not at all. So restriction should be B should not be 0. Don't try by all means to divide by a 0, because this will not be, it will not exist. That one we just say it is undefined. In mathematics, that is meaningless. So it could be any other number. For example, in the first group of numbers, where we talk of the rational numbers, I can have here a number 2 over 5. It's a fraction. Most especially you can be able to tell that if the number can be expressed as a fraction, then that is a rational number. Definitely, if you look at this number here, you can be able to tell that this number is just directly expressed in the form then. And you can tell that A, in this case, is 2. And B, in this case, is what? 5. Therefore, we categorize 2 over 5 as a good example of what? Rational numbers. I can also have another example here. This is example A, example B. Another fraction which is improper, 5.5. It's not in that form, A over B, as you can see it. But now in the definition of said, can you manage to express it in a form of A over B? To have two numbers, one like in numerator, another denominator. So you see by the operation of mathematics that we know on how we express the fractions, in the position to convert this one into a proper fraction, where you have 2 times 5, you get a 10, multiplied by 1, you get 11. So this number is as good as writing 11 over a 2. If you look at 11 over 2, is as good as writing what? A over B. So which means 5.5 numbers of that form are part and parcel of what? Rational numbers. I'm managing to express it in the form of what? A over what? B. What else can I have? Look at this. 0.5. This I can take it as example C. If one likes 0.5, this is as good as dividing 5 by what? A 10. Which can give you a half, 1 over 2, or leave it as it is. I am expressing it. Not necessarily that the numbers will just safely express themselves like that. No, you can manage, or else the number is already in that form of A over B. So this 5 over 2, which is coming from of 10, 5 over 10, this is a good example, again, of a rational number. You'll be able to say my A here is 5 and my B is what? A 10. And lastly, there are some numbers which are just like numbers by themselves. They're just numbers. The whole numbers are such. Like a category of a number, a whole number like 11. You can have 20, 30, 40, whatever number. Now we pick it like that. It's not a decimal fraction. Here, it's a category of all decimal fractions. Here is a category of what? All numbers which are improper in the fraction. All numbers which are what? Proper fractions. The rational numbers. Rational number of that group. Rational numbers. And again, here, if you look at this one, 11, somebody might be asking, how come 11 be a rational number? As a mathematician, you're able to know that say 11 is as good as writing what? 11 over what? 1. From our guide here, B should not be 0, can be any number. So 11 is giving us 11 over 1 is the same thing. So here, it means the same format, A over what? A over B. You'll be able to tell here that say my A is what? 11. And my B is what? We talk of what? 1. So you can see all the numbers that you have, we talk of all integers are already in the category of what? Rational numbers. So we talk of the rational numbers, we talk of numbers which are in the form of A over B, just from my few examples which I've just given you here. Hope everything is clear on the rational numbers. And you can have so many examples by A, B, C, and D, they'll give you a good guide. Now, let us look at this other story that will take us into this category, which is not very easy for you to express that number in this form of A over B. Right, and the ones which you can give them as irrational numbers. Look at this. If I may write a number like square root of 16, and also write here square root of here I have two numbers but they are in roots, and square root of 7. Look at the two numbers in roots. If I can test this one to try to fix this number into form of A over B, that will be possible. Because we all know that the square root of 16 is what? A 4. And that 4 can be converted into what? 4 over 1. So it means root of 16 is what? A rational number. But now when it comes to this, I don't know if that one is possible, because if I take the square root of 7, it is going to give me decimal numbers. And that will just be going, it will be like talk of 2 point something, a number which you just correct to certain decimal places. You force it. But you're talking about the whole number has to be converted in that one. So it means this one is very difficult for you to convert it into the form of what? A over B. You're going to divide by what and what? You take the square root of 7. It gives you 2 point something, just like the numbers which goes like 2 point, they just go on until infinity. So it means root of 7 is not possible to be converted into what? A over B. So such numbers, root of 7, is a good example of what? Irrational number. Other examples of irrational numbers, apart from A being square root of 7, we have got what we call it a pi. That one. This pi is just a result of dividing 22 over 7. Because most of the times in the exam, they like take pi as 22 over 7 or a decimal number. So it found that if I try to divide 7 into this one, if it over pi, it's the number that goes like 3.14, something like that one. So the pi itself, it simply means the whole value. This one does not end, it just goes like that one. 3.14, something like that. The 22 over 7 is just a collection to a certain number of decimal places. But now they've considered a pi in this system being the 3.14. This number is just a collection to a certain decimal places, in this case 2 decimal places, but this number just goes on like that one. So it's very difficult for you to express that number into a form of A over B. That's why most of the time we just talk of the approximation, where we are just using 22 over 7. So pi is another good example of what? Irrational number. You can't express in the form of A over B. Again, it's not always a square root. You can have sometimes 4th root, talk of 5th root, things like that. Like say for example, if I can have talk of the cube root of 11. They were trying to look for a number that you can multiply 3 times to get 11. It's not there. But if I may write cube root of 8, I'll be able to find the cube root of 8, which is 3, which is 2, not 3 but 2. So 2 can be turned up to what? 2 over 1. It's rational. This is a rational number. It is the category of rational number, but not this one. It's not easy. So this is irrational, this is rational. Fine. So what you first are supposed to know before we introduce ourselves into the surds is that if we talk of rational numbers, what are they? And now if we talk of the irrational numbers, what are they? So simple as it is, rational numbers, numbers which can just express in the form of A over B, or a number expressed in the form of a fraction. But please don't regard B to be a 0, because that will be undefined. For irrational numbers, numbers not, that's the negative part, which cannot be expressed in the form of A over B. I've given at least good examples that are able to split the numbers that you're interacting up with into 2 categories, rational and irrational. Now let us get ourselves now into surds. Having understood what rational and irrational numbers are, it will not be now difficult for us to know what surds are. when we talk of a surd, these are just roots of rational numbers. For example, look at this one. I have got, like, say, talk of a 5. We know that 5 is a rational number. I'm defining a surd here. 5 is a rational number. It can be converted into 5 over 1. Roots of rational numbers that are irrational. You see that? So you can take it from that angle where I was talking of this 80 is a rational number compared to 5. I take the root of 5, roots, and I also take a root of 8. This 5 is a rational number. 8 is a rational number. But now if I can try to take the square root of 5, it will not be possible there for I to convert it into A over B, because it will just be a number which is a decimal number that needs to be approximated. So it means here, if I'm taking the root of a 5, it's not possible. It means me like that one. So it means the result here is irrational. But if I compare with root of 8, not necessarily root of 8, let's talk of the cube root of 8. Look at what you have there. You'll be in the position to take the cube root of 8, which gives you what? A 3. We are here talking of the cube root of 8. It's not 3, but here it was just an oversight, which is supposed to be what? A 2. This is just like one of the main objectives. Here we just introduced ourselves into what surds are by knowing the rational and irrational numbers. Right, this topic is not all that difficult, just very simple. Right, so it means now the rest of the discussion here in this topic will just be there about the numbers which are not rational at all. We'll just be going upon them. So if you had followed all those objectives that I lined up earlier, it'd be just like now, how do we simplify the surds by those operations? Addition, subtraction, multiplication, division, and such. So it means now here, if we talk about that, it means our discussion will be the terms which have got roots, mostly like the ones we have them here. Right, so now here to have a larger space, let me remove this start here, and we take ourselves into the simplification of surds. Right, you enjoy this topic. It's one of the simplest topic in book 3. Right, and we'll not even take time to finish this one up, and after we'll even take ourselves into the third topic that we'll be talking about angles as such. But first, let's focus on this one and finalize it out. Right, the next thing now we'll do now is just a matter of expressing the surds in the simplest form if we had follow those objectives. Expressing surds in the simplest form. Right, surds. You know what is here is just more like what we have already been doing in the little numbers that we have had. Like, say maybe you are given a fraction. So for example, they give you maybe talk over 18 over 24. You've been asked most of the times to express that one in the simplest form. And it would come into say 18 over 4 over 24. It's just like having smaller terms. Instead of having 18 and 24, you could consider what factor can divide into 18 and 24. So you find that in 18, there's the highest common factor, which is a 6, can get into 18 and also into 24. So when you divide by the common factor there, what you have are simpler numbers. Like say if 6 goes here, go 3 times. 6 here goes 4 times. So it means 18 over 24 give us 3 over 4. So it means 18 over 24 has been simplified into 3 over 4. So now, what about the surds? How do you simplify the surds? Right. So let us have the following examples. Right. Can you even copy these examples? Right. simplify the following. Right. We are given A, talk of root of 12, B, square root of 27, and then C, we talk of the cube root of what is 16, and D, we have got square root of 18 over 28. Right. So you can see what we have here. For example, A, B, C, and D. It's not easy for you to get the square root of 12. It's not direct again to get the square root of 27. You can't get the cube root of 16 directly, and you cannot take the square root of 18 over 24 directly. So all the terms or expressions which are there, for examples, are defined as such. Right, so by the first just the introductory part of the simplification process, I gave a good example how could we always simplify the fractions. We divide by common factor. Now, what if a term comes in the form of a surd like these ones here? What is it that we do? Right, so I'll be at least always direct to the point, right? So that you'll be able to at least follow these ones and not be off track. Right, there's only one way that we use in order to simplify the surds. For the fractions, we divide by common factor, like it was for 18 over 24. You saw I get 3 over 4. But here, take this. What is there is first of all understood like this, like say square root of 12. I want to take the square root of 12. I know this is not possible. So what do we do in this case for us to simplify this one? We cannot leave it as it is. You might be able to find out that say a number inside the root there, right, is always a rational number. Like here 12. If you take the square root of 12, the result is a rational number. That's why I call this one as a surd. So to simplify this one in the simplest form, what you do is just a matter of finding two factors of the number inside. Like here we talk of 12, there we talk of 27, here we talk of what? 16. One factor, you can leave it to be what? Irrational factor. Find two factors. Out of the two factors, the other factor should be irrational, or the other factor must be irrational factor. Like say for example, we have square root of 12 here. What does that mean? I need to find factors of 12, which are 2 in this case. I'll choose a factor 4, which has to be multiplied by 3 in this case. If I look at the two factors of 12, which is 4 and 3, I would see that if I can write 4 in the root alone and 3 in the root alone, it looks something like this, which is the same root of a 4 multiplied by root of a 3. You'll be able to see that root of a 3 is the irrational factor of what? Root of 12. But root of a 4 is not irrational factor because you are able to get the what? Square root of a 4. So once you have done this one, you do the operation there. Very freely. So it'll be like what is the square root of a 4? You have with the 2. So that 2, it will be like now outside the root and give you a 2 in this case. But for the root of a 3, you can't have it. It's irrational. So we are here, we are not even interested with the decimal numbers. What we make here is just like the whole numbers as such. If you can't operate the number as a whole, you leave it in the root as it is. So here it means you have square root of a 4. Sorry, that's the square root of a 4, which gives you a 2 to be multiplied by square root of a 3, which will be just like now 2 root of a 3. Right. So that's your answer. So you look, if you look at the root of a 12 and look at the 2 root 3, the 2 here means the same, but not different. If you do the operation, you can even go in the reverse system. You still won't get this one out. So that will be discussed in the next lesson that we have. But now let's just focus on how we can simplify the stats. So I repeat, find two factors of the number inside, which is irrational, but the factors of which one of each should be the irrational factor. Like here, the irrational factor is the 3, root over 3. Root over 4 is not the irrational factor. Then you simplify, get the root of the irrational factor easily, like you get a 2 here in this case, and then finally the root over 3, you can't have it, leave it like that. B, you're going for root of 27. The sum. For root of 27, you get 9 times 3. And this is the same as writing square root of 9 multiplied by square root of what? A 3. You can have the square root of 9, which is the 3. Square root of 3, you can't have it. So you just have to multiply that 3 by root over 3, which comes something like this one. Right. So also try to follow this some other step. Just say maybe if I've got a root of a number whereby we've got two factors inside, that is just as good as separating those factors with the roots of that same kind. Square root of 4 times 3 is as good as square root of 4 alone multiplied by square root of 3 as it is here. Right. So it's just like a simple story of discussion here. Just very simple. Let's go to example, that's what? Example C. The same guide. You have to see it not being used differently. It's the same guide that is there done in all areas of concern. We talk of all expressions are simplified by that. So the same way, if you look at square root of 27 is as good as writing 3 root of 3. So this is the same like that one. Here, all of that, this one has been now written in simplest form, has been expressed in the simplest form. Going for the cube root, because it does not always be the square root, it can be any root of a number. 4th root, 5th root, things like that. So what do I do? Having done the example A and B, I will need you at least to finalize the last two examples that say C and D by yourself. You try that one and write it out based on the principle that we have just discussed on how to simplify the stats. Remember, we are talking of simplifying the stats by this guide as to say, find two factors of a term in a root, but one factor should be the irrational factor. So it should be in the position to at least simplify one factor, and the other one is not simplified because it is irrational. So what we have done by example A and example B, do the same for example C and D. That is your exercise. Additionally to C and D, I will need also you to write the following. So which means you have like 4 problems to work on. Right. So this is just like additional exercise. I'll take that, say additional exercise. Right. You need to thus simplify. Right. Now I'll talk of E because we already have D up there. That's cube root. Now I'll give you this small number, 0.08. Applying the skill that we have discussed in example A and B. Will you be in the position to think about this one? Try it out. And again, F, where we have got now term, which are just like variables, not as numbers. N squared over h to the power 4, k squared. It's more like application of what we have just done. Right. So this juncture, my dear students, we need to stop here. Right. Just to remind you what we have just done, we were in that position to discuss on how we can simplify the stats. But firstly, we are there to know what rational and irrational numbers are, and then they to be conversant with the terms which call them as stats. Right. And the last thing that we have done is on the simplification of the stats. So I'm happy that we have been together. Thank you very much for watching. And I hope we'll be together again in the next video. Please let us finalize together. We'll be discussing about the word simplification of stats by addition and subtraction. Thank you.